Now that we have started looking at dilations, we're going to do a little bit of review from maybe something that you learned in algebra to help you proceed through similarity in this topic. And so we're going to backtrack a little bit here, and we're going to talk what a ratio and what a proportion is. Okay, we need to use ratios when we talk about similar figures. So let's review what a ratio is from Algebra 1. Okay, a ratio is a comparison of two quantities. Okay, so we write ratios in several ways. Most often we write a ratio, more common than anything, we write a ratio as a fraction. And when we write ratios in this chapter, we're going to be comparing two quantities, we're going to be comparing two different sides in figures. Ratios can also be written with a colon there. That would be read 2 to 5, or we could write it out with words and say 2 to 5. A ratio is comparing two things, so the number 2 is being compared to the number 5. Might be boys to girls, it might be left-handed people to right-handed people, blue eyes to green eyes. We're comparing different quantities. Okay, here's an example. Okay, it says the ratio of boys to girls in the class is 2 to 5. That's the ratio. There are 28 students in the class. How many boys and how many girls are there? Well, there's not just 2 boys and 5 girls. And here's another thing. When the numbers are listed like this, you got to go back and connect the words. Since boys is listed first, boys to girls, this number represents boys, this number represents girls. But there's not just 2 boys and 5 girls. That would be 7 kids in the class. It says there's 28 kids. So there's a couple different ways you could go about finding the actual number of boys and the actual number of girls. Okay, one is that you could keep writing equivalent fractions. So we know that 4 over 10 is the same as 2/5. I get that by simply multiplying both the top and the bottom by 2. Okay, but if there were 4 boys and 10 girls, that's only 14 kids. And so I would have to keep going, maybe multiply by this 2 again, and I get 8 over 20. Okay, now if there's 8 boys and 20 girls, is that 28 students in the class? And you would say, yeah, that's an equivalent fraction that's going to reduce itself down to 2 over 5, but the actual starting number was 8 to 20. So that's one way you could go about finding the actual number of boys and girls. Another way to do it algebraically is to take that ratio 2 to 5 and to put a little x with it. And the reason that we put x on it is because just like in a fraction, I have to multiply the top and the bottom by the same value. To get to the actual numbers, we have to multiply by the same value. We just don't know what that is yet. So we use x to represent that number. Okay, and if there's a total of 28 kids in the class, we take 2x and we add it to 5x, and we set it equal to the total number of kids in the class. And we can solve that. We know that 2x plus 5x is 7x. Okay, we divide both sides by 7, and we get x equals 4. And that tells us what we need to multiply our 2 and our 5 by to get the actual numbers. 2 times 4 is 8. 5 times 4 is 20. So we knew we had 8 boys and 20 girls in the class. Okay, that's one way to solve when they're asking you for the actual number. Okay, that's a ratio. Okay, a proportion is an equation. Okay, a proportion is an equation stating that two ratios are equal to each other. Remember, a ratio is a fraction. So this ratio says 2/5 is equal to 8/20. I have a ratio on both sides. When I set them equal, I create what we call a proportion. And is that true? Does 2/5 equal 8/20? We would say yes, because their cross products are equal to each other. 2 times 20 is 40, and that equals this product. 5 times 8 is 40. Because their cross products are equal, we say that those two fractions are equivalent. Okay? So we can use that idea of cross products to solve different proportions and find missing values. For example, at the bottom of page 2, if we can set up a proportion, we can solve a value of unknowns. This says 4 over 7 equals x over 20. So the way to solve that is to look at the cross products. I can take 4 times 20. 4 times 20 is 80, and I set it equal to this product, 7x. Now, that's something we know how to solve. How do we solve for x? Okay, we're going to divide both sides by 7. So x is equal to, and you can see the solution over here, it comes out to be a decimal, so instead of using an equal sign, they make it a wavy equal sign, saying that we have to round our answer, but we get 11.43. It's an approximate answer. You are going to get decimals on this unit, and that's okay. Pay attention to the directions and see what you're supposed to round to. Okay, a couple other types of problems that you're going to encounter on your worksheet. Okay, sometimes the ratios don't have just single values, but it says x. I'm going to rewrite this just to make it a little bigger for you to see. This says x minus 4 over 5 is equal to 2x minus 6 over 3. When you have more than one unit in the numerator, like we've got an expression, we're still going to do the same thing. We're still going to take the cross products. So I'm going to take 3, but I have to put this in parentheses. I need to take 3 times all of that. And I set it equal to this product. Okay, and I'm going to take 5 times all of that. Now, how would you solve that algebraically? Well, hopefully you're thinking, well, I have to distribute here on both sides of the equation. Okay, so we're going to get 3x minus 12 equals 10x minus 30. Make sure you distribute. Now I've got to get my x's on the same side of the equation. I'm going to subtract 3x from both sides. So negative 12 is equal to 7x minus 30. Add 30. And I'm going to get 18 is equal to 7x. When I divide by 7, x is going to come out to be, and again, it's not going to be even. Okay, so that's going to be 2. I've got to grab a calculator. I'm going to take 18, and I'm going to divide it by 7, and I get 2.57. Okay, again, make sure you read the directions and see what you're supposed to round your answer to. That's being rounded to the 100th. If I wanted to round it to the 10th, that would be 2.6. So read the directions. Okay, last type of, you're going to get a few word problems, and they want you to write and solve a proportion. So we want to solve, well, first we got to write a proportion, and then we want to solve it. So it takes 6 drops of food coloring, 6 drops food coloring to 20 ounces of frosting. So I write a ratio comparing those two quantities, the drops of food coloring to the ounces of frosting. And it says how many drops, this is the part I don't know, how many drops will be needed to tint 45 ounces of frosting. And again, when you write your proportion, make sure that your same quantities are in the same locations. So my drops of food coloring were in the top of my ratio. Over here, this has to be the drops of food coloring at the top of the ratio. Both these bottom numbers represented ounces of frosting. So the positioning of your ratio is important. Once you have your proportion drawn or written, you can go ahead and you can solve it. You're going to take your cross products. You're going to take 6 times 45. On my calculator, I'm doing 6 times 45. I get a value of 270, and that's going to equal this product, 20x. Okay, divide by 20. And I'm going to get x is equal to 13.5. Okay, that actually comes out even. I don't have to round that off. So I can use an equal sign on that. I don't have to use a wavy equal sign. But it would take 13.5 drops of food coloring. Okay, there's a worksheet for ratios and proportions.